Hello guys, we will continue developing our language. In today's session we will handle expression like arithmetic expression, logic, comparison, and term, and so on. So let's start. So I will go to the main function compile. So first of all I will make some comment to show you the grammar of our int language. So it starts by the entry point program, and the program, it's a bunch of declaration, and finally the end of file. This star here, it doesn't mean only multiple declarations, so 0 or many. So then for declaration in this video we will focus only on expression statement, and expression statement are defined like so. It's expression followed by a semicolon, and then for expression, for now it's a logic OR, and for logic OR it's a logic AND, OR, and logic AND 0 or many times. So then we should define logic and logic AND, you get it, it's logic, it's equality. So I built this grammar to follow the precedence. As you see, the more I get deeper, the more the precedence is higher. So in this logic AND we have equality, or we can have AND and equality, as many as we want. And then for equality, it's a comparison. It could be a comparison, or equal, or not equal. This is the tokens in this equality statement, and followed by comparison, and also as many as you want. And then we should define comparison. It's a term, and in the comparison we have greater or lower or greater equal or lower equal. And then we have term, and all this is as many as time you want. And then we should define term. Term is a factor, and we have plus and minus or minus, and factor, also as many as you want. It could be 0, which could be whatever you want. So then we should define factor. So the factor is a unary or a star to define the multiplication, or slash for division, and unary. And then we should define unary for expression that are unary, that have operator unary. It's a not or minus, and followed by a unary or primary. and for primary is could be true, keyword true, or false, or nil, or some identifier, or string, or number, or some grouping expression. And we come back to expression. So this grammar denote the end language, and as we get deeper into projects we will modify that so it fits on our language. So in the language theory or person theory or whatever, these are called non-terminal and these are terminals. This is called terminals and these are non-terminal. It could be functions that we will declare, which are defining program function, expression statement function, expression, and so on. And these are our language: number, string, identifier, nil, false, true, and so on. So we need a bunch of utility functions that will help us parse these. So the first function we need is checking static to return a boolean. We check the token type. We check if the current token is equal in type to the argument type. So let's do that. Parser, the current token is equal type. If it is equal the current one, it will return us true. The other helping function is match. This one also it take the type and it check if it is not the type, it will return false. If it is the type, it will advance the cursor by 1 to the next token and we will return true. Other function called also, it's a static function, consume. It consume a token and it check if it is that token, if it is that type, then it will continue, it will advance. If it is not, it will return an error. So all these function so I did something bad. I need to redefine that. Static void consume token type and the message in case of error. So let's define that. So we will check if the parser current the type equal type, and if so, we will advance our cursor and we will return nothing. Otherwise, we will print that we had an error, and the message is the argument passed to this function, which is a useful function. Also, we need some function that can emit a byte to the VM. So let's do that. Static void emit byte. It's a byte, and we will write directly to the chunk passed by the VM. So let's do that. Write chunk. We get the current chunk. This one is the chunk that VM give to the compiler, and we pass the byte, and also we need to pass the line. Also, I need a way to emit 2 bytes at the same time. It will be useful when we will emit something like op constant and the constant. Byte 1, byte 2, and we will use the emit byte 1, and emit byte 2. So we need another useful one called emit constant. As its name suggests, we will pass to it the constant, and we will emit bytes up constant and the constant. So after that, we need to define another useful function that make constant from a value. So we pass value, and we call the write constant function. Get current chunk, and we pass that value. Then we will check if that constant greater than the maximum of a byte. So I make sure that I didn't store something greater into the chunk, because remember, the chunk it store the bytecode, and the bytecode is defined on 1 byte. So in that case, I will printf an error to the standard error, and I will say error too many constant in a chunk. So we will return 0. So we return the constant casted to a byte. So I will need a function called expression that start parsing expression. So I will do that by calling the parse precedence, and I will start by the lower one is assignment. Okay, it should be defined here. Okay, that's good. So I need to delete all these because I didn't. So in this video we will not hard code the bytecode. We will be generated dynamically. So let's do that. So first of all, we will initialize our scanner. We will pass it the source code, and then the current chunk will be the chunk passed by the VM, and also we will advance our cursor for the first time, so that ensure that the previous and current point into the first token. And parser had error, it's for now false until an error is erased. Then I will do a loop until I didn't match a token and the file, and then I will do declaration, call declaration, and finally to the VM to start executing, I will do up return. So finally, after declaration, remember this declaration is declared in the grammar, and token and the file is checked by that, and this submin is a lot of declarations. So we will do a loop until I find and end the file. So this I will emit a byte to say to the VM, you need to halt. So as usual, we need to print some debugging. So debug print code, and then we will end that. And if, and we will disassemble current chunk script, and finally we'll return false if the parser had an error. Otherwise we will return true. So let's define these functions declaration. So static void declaration, and in declaration we will call expression statement. And expression statement is defined like so. It will handle all expressions. We will call expression, and finally we need to consume a semicolon. If it is not semicolon, we need to print an error to the user. Expect semicolon at end of expression. So it's like in our grammar, I call expression, and then expression it will handle all these by our prod parser. And finally we need to check if we had at the end of the line. So what we need in this session, we need to handle expression like plus and minus and division and multiplication. To do that, we need to go to our table of rules and go to plus, and plus it's a infix operation. Then we will do that the binary function, it will handle the plus, and we need to give it a precedence, its term, and for minus also its precedence is term, for star is factor, and for star also its factor, and all these are handled by the function binary. Binary, and this also is binary. And we need also to handle numbers, because we need to do something like 2 plus 3 plus that. So it's a prefix operation. We call the function number to handle that, and it has no precedence. So let's define this function up here. So it's a static function, static void binary. Let's do only the prototype here, number, and let's define that before expression statement. Okay, we have here expression statements. Let's handle first of all the number, the easiest one. So it's a number, so I need to remember the parser, it reads characters, so I need to convert the string, the character into a double. So we'll use this function called string to double, and we pass the previous character star, and then we emit the constant. We will make the constant from that number, and we will emit that constant. So this will emit finally up constant to the VM, whatever the constant. So next, let's define the function binary that handle plus and minus and multiplication and division. So to do that, we should define binary, and first of all we need to catch the previous token, and we need the precedence of that token, of the current one. Get precedence rule, parser print type, and we need its precedence, and we need to parse, to call the parser, our parser. We'll cast that, and we need to pass it a precedence higher than the current one, because I don't know if we will have a higher operation after this token. So I did that, and also that will handle the right associativity until I handle the right the left associativity until I handle the left operation, and then I will continue to the next one. So after this I will do a switch case on previous type. So in case token plus, I should emit byte, op add, and break. And then in case of token minus, I will emit byte op subtract and I will break that. And in case token star, I will emit byte op mul, excuse me, emit byte op multiply, and I will break that. Also case token slash, I will emit byte op divide, and I will break that. So we need also to add this operation to the VM, so the VM can interpret that, because our VM cannot interpret, it doesn't know these operations, so we need to add to our VM. So let's go to our VM to handle that. First we need to go to our module check, and we need to add this operation in opcode. So op add, op subtract, op multiply, and op divide. Okay, so we need to go to our debugger to add these function to add these disassembling. So vim debug.c, so we'll add that case op add will return simple instruction, op add and offset. In case of op subtract, we will return simple instruction, op subtract offset. And case of multiply, we will return simple instruction, op multiply offset. And finally for op divide, we need to return divide, also simple instruction, op divide offset. So let's go to our VM and add this instruction, vm.c. So first of all we need to add a macros that handle binary operation. I will call it binary up, and it take operator as a parameter, so we will do while false. I did that just to, because I will define here value b, and I will pop that one, also value a, and I will pop that from the stack, and then I will push a operator b. So that's it. So let's add this backslash. So let's undefine that. So you will ask me, why do you do while and false? Because the only reason why, because when I will do case op add, I will call the binary op, and I will pass plus, and then I will break that. But remember, if I have also case of subtract, I will do binary op subtract and break. Remember, macros is something pre-processed by C, so it will put this as it is in that place. So I did that just to solve the issue that C will see that B and A is redeclared, because it will put value B and value A here, and then we will put value B and value A here. So it will raise an error that says the B and A is redeclared also in op subtract. So I did that just to encapsulate that in subscope, so to avoid that problem. So let's continue. For the other rounds, we have up, multiply, and I will call the macro binary up, and it's multiply, and I will break. For the final one, it's up, divide, and I will call binary up, divide, and I will do a break. So let's run that and see what will happen. I will hope there is no error, but we will see. So let's make that. Make all. Don't worry about this, it's just a warning. We will be worried about errors. So it says implicit declaration for this one at the line of 146. So let's go to that, field compiler.c. So in 146 we have get current chunk. So get current chunks, I think I didn't define it. So let's search about that. Get current chunk. So I need to declare a chunk called current chunk. It will be null, and then I will define a function called static, and we'll return the get current chunk, and it will return the current one, return current chunk. So as that, so we'll save that and we will see. So let's clear that and we call. So it's a small spelling and 202. Precedence. Okay, let's clear that. Okay, it's a simple structure in the back. Okay, it's misspelled, so let's go to debug.c at line 36. So return simple instruction. Okay, let's rebuild the project. Okay, something fun. Okay, misspell this. Okay, let's go to vm.c. So I need a semicolon here. Okay, in break also. Okay, let's save that, and let's clear, make all. So everything is okay. So let's run our int interpreter. So let's do 2 plus 2. So as you see, this is the bytecode of constant 0 and the value is 2, and the index is 1 and the real value is 2 also, and the operation of and a halt. So the state of the stack is 2 at the first instruction. For the second one, for the second bytecode is 2, it load 2, and for operation add, it pop these 2 and add it and return into the stack, and the VM will halt. So let's do something with mixed operation like that. So if I didn't mention the semicolon, it should return an error. So as you see, error at the end, da, da, da. So 2 plus 3, I should, the first, it should be handled this, 3 times 10 is 30, and plus 3 is 32. Okay, as you see, it's 32 on the stack. Let's see the bytecode. Okay, it loads 2, and also it loads 3, and it loads 10, and it do multiplication, and then finally the addition. So as you see here, it's 32. So let's do the inverse. 3 times 10 plus 2. Okay. Normally it should print 32. So let's see the bytecode of constant. It loads 3 and it loads 10 and it loads 2, and no, I didn't want that. So to solve that issue, I think I have an issue in our binary operation. So let's go to it and go to compiler.c. So I will, it's this, I will name it token type. It's the operator type, and I will get its type, and then I will need not the current but this operator type. I need the precedence of that one, operator type, and that's it. So let's come back and rebuild the project. Okay, we have something wrong, so let's go back. Okay, it's not the, that's operator type. So let's rebuild the project. Let's clear and so let's test 3 times 10 plus 2. It should print 32. Let's do the inverse. So 2 plus 3 times 10 also is 32. So guys, as you see, let's test that in some example file. So let's see if we have a sample. So let's create a one vim sample and let's remove that, and we will do 2 plus 3, 2 times 3, and let's do something else. 0 times 3 plus 1. So So let's interpret that. So for the first instruction we have to, let's cut that and to see the content of the file. So for the first one we need to have 6. So we load 2 and we need to have 5. We load 2 and 3 and we add that. As you see, we need we load 2 and 3 and we add that. So for the second instruction we need to load 2 and 3 also, and we multiply that. As you see here, we load 2 and 3 and we multiply that is 6. So the stack we have 5 and 6. So for the next one we need to load 0 and load 3 and multiply that. So 3 times 0 is 0, and we need to load 1 and do addition. 0 plus 1 is 1. So the final stack is 5, 6 and 1. 5, 6 and 1. So guys, this is the end of our video. So now in this video we have a simple calculator. This is the beginning of our end language. At the next session we will treat comparison and logic, and we will also treat if statement and while. So bear with me to the end. So at the next session.